Good afternoon to all. Good afternoon. Good afternoon to all. I am Virish Manes, faculty in the Department of Mathematics, Keller Society, SK Arts College, and HSK Science Institute, Mumbai. So, Karnataka government implemented NEP at the undergraduate and postgraduate level from the academic year 2021-22. Karnataka University Dharwad was the first university in the Karnataka to implement it. With this implementation, there was a lot of change in the course structure, syllabus, grading system. Also, earlier in the colleges under Karnataka University, there were no math labs or practicals. With the implementation of NEP, math practicals have been introduced. Here we are going to verify the results and theorems that we study in the math through the softwares like MATLAB, Scilab, Maple, Maxima, R language, etc. So here, for the sake of our students, so Department of Mathematics of Keller Society, SK Arts College, and HSK Science Institute, Hubli, in association with the RT Societies, Arts, Science, and Commerce for Degree College, Ranebenu, has organized a one-day virtual workshop for students on the practicals on algebra and calculus based on the NEP syllabus. So here we are going to start the event. So firstly, I like to welcome uh, Kavita Patil Madam, Secretary of the Department of Mathematics of RT Society, Arts, Science, and Commerce College, Ranebenu. Ma'am, it's what you.
Sir. Okay, sir. Thank you. Hello, I am audible. Hello.
Yeah, ma'am, you are audible.
Okay, sir. Thank you. Good afternoon, everyone. I am Kavita from RTS College, Ranebenu. Extremely happy that Department of Mathematics, RTS College, in association with Kelly's SK Arts and HSK Science Institute, Hubballi, has been organized one-day virtual workshop for students on practicals on algebra first and calculus. First, NEP syllabus. At the outset, I would like to extend hearty welcome to Dr. Prabha S. Mandalagiri, the resource person of today's virtual workshop. Secondly, I, on behalf of our institution, offer a warm welcome to the principals of both the institutions. I present a cheerful welcome to Dr. Archana Yam, the organizing secretary of this virtual workshop. Finally, I present a delightful welcome to the students who are present in this virtual workshop. Thanks for this opportunity. Thank you, one and all.
Thank you, ma'am, for your warm welcome. So here we are at the main part of this event. So we are going to start a technical session. We have Dr. Prabha S. Mandalagiri Madam, HOD of Department of Mathematics, SK Arts College, and HSK Science Institute, Hubli. So before starting our technical session, so I like to introduce our resource person. So Dr. Prabhavati Mandalagiri Madam completed her BSc from PC Javin College, Hubli, and MS in Mathematics and PGDCA from KUD, Karnataka University, Dharwad. She went on to complete her MPhil from Gulbarga University, Gulbarga. Then she completed a PhD from Rani Chennamma University, Belgavi. She started her teaching career in 1992 in SG College, Koppal. Then she gave her service in different institutes. From 2005, she is working as an assistant professor in KLE institutes. Earlier, she worked at RLS Institute, Belgavi. From 2010 till today, she is working in SK Arts College and HSK Science Institute, Mumbai. She has taught at various courses in mathematics and computer science at both undergraduate and postgraduate level. She has also developed many software, to name few, a payroll software and a deduction slip for HC College, Koppal, Markstart software for first year for HC College, Koppal, a payroll software and income tax performa, and library software for LP Science College, Gulbarga. She has also published 13 research papers in international journals and 3 research papers in concerned custody. So that's all about the madam. So now let's start the technical session. Hello, ma'am. Prabha, ma'am. Prabha, ma'am.
Hello.
It's what you.
Audible?
You can.
Audible?
Yeah, ma'am. You are audible. You can start the session.
See, it is great opportunity to meet you all in virtual platform. Let me start with the details of practicals on algebra and calculus. Then Scilab is for really dummies. It is introducing an open source alternative to MATLAB. The introduction of the Scilab. What is Scilab? Scilab is a software package and scientific engineering computing, and it is similar to the MATLAB. Scilab is a tool of numerical computing. Scilab is a free and open source software, and it can be downloaded from the www.scilab.org. Scilab is also matrix oriented, and just like a MATLAB, it allows all the matrix multiplication and 2D and 3D plottings and animation, etc. It is also open programming environment. It allows the user to create their own functions, and it is also editor has built-in though elementary debugger. Then it is an interpreter. Interpreter means the line by line it works the programming part. And the Scilab advantage is numeric computing is a better suited for a complex task than the symbolic computing. Compared to the Scilab and Maximum is the symbolic software, and the Scilab is suitable for complex tasks than the symbolic computing. Then it is also includes the MATLAB to Scilab translator, and also data plotting is very simple in this Scilab. Now you can see how to install the Scilab. You have to download the Scilab from the www.scilab.org. From there, you have to right click it and install it. The installation procedure you see here. Here Scilab 6.11 exe file is there. Double clicking the Scilab 6.11 exe file, and you'll get the console like this. Then go on out here. Next, then have to finish it. Then here have to finish it. Then you can install the Scilab version 6.11. When you are installing the 6.11, the older version also it doesn't uninstall. Then when you are double clicking and launching the Scilab.
Hello, madam.
Madam.
Yes.
Madam, voice is not clear.
Voice is low, very low. Voice part कम है दम.
Okay, I will check it. Just a minute. Now you see? Hello? Hello? Hello?
Ha, madam.
Correct ಇದೆ ma'am. Hello, correct ಇದೆ.
Madam, correct ಇದೆ.
Correct ಇದೆ ಈಗ?
ಹಾ ma'am.
Madam, correct ಇದೆ.
Can you see the screen?
Yes ma'am, it's visible.
Visible. See, when double clicking the icon to launch the Scilab environment by default consists of the following docked windows. It contains a console. This is a console. This is a files, a variable browser, and the command history. When you are double clicking the icon launch Scilab environment, you can look like this. Now, before going to the Scilab, you should know the meanings of some commands. Means what is an argument? Argument means what here? The values provided as inputs to the command input arguments or returned by the command output arguments. Command as a user return statement that provides the instruction to the computer. That is also a statement is often called the alternative. Statement and command are the both different. Then everyone you are familiar with the default.
Madam.
Tell me.
Madam, ಅದು ನಡು ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗತ್ತ ನೋಡ್ರಿ ಮೇಡಮ್.
ಹೌದಾ?
ಹಾ, ಈಗ ಮತ್ತೆ ಲೋ ಆಯ್ತದ ವಾಯ್ಸ್.
Just a minute. ಈಗ ನೋಡಿ ಅಡಿಬಲ್ ಇದೆ. ಹಲೋ
ಎಸ್ ಮ್ಯಾಮ್ ಆಡಿಬಲ್ ಇದೆ ರೀ.
ನಡು ಬ್ರೇಕ್ ಆಗ್ತಾ ಇದೆ.
ಅದೇ ನಡು ಏನೋ ಸ್ವಲ್ಪ ವಾಯ್ಸ್ ಫುಲ್ ಲೋ ಆಗ್ಬಿಡ್ತೈತಿ ಮೇಡಮ್.
ಹೌದಾ? ನಾ ಹೈನೇ ಇಟ್ಟಿನಿ ಇಲ್ಲಿ.
ಆಯ್ತು ಹೇಳ್ರಿ ಮ್ಯಾಮ್, ಆಯ್ತು.
ಹಂಗಿದ್ದಾಗ ಮೆಸೇಜ್ ಹಾಕ್ ನಂಗೆ.
ಆಯ್ತು ಮ್ಯಾಮ್, ಆಯ್ತು ರೀ.
ಓಕೆ ಓಕೆ. Can you see the screen?
Yes, ma'am.
See, the default means the action taken or a value chosen if none has been provided. If you not given any values, means default means automatically takes the default value, that is without giving any value, automatically it will take the default value. Yes, display means to output the listing of the text information on the computer screen. The word also echo is also important to display the commands or other input typed by the user. Execute means to run the program or carry out the instructions specified in a command. Return results provided by the computer in response to the command. See, although the very important, the two words are very important, prompt and the cursor. Without that we cannot do anything. Prompt means a character or series of characters that appears on the screen to request the input of the user. If a prompt is be displayed, then only will come to know we have to give the input.
Madam,
tell me.
Ma'am, ಮತ್ತೆ ವಾಯ್ಸ್ ಕಮ್ಮಿ ಆತ್ರಿ ಬಾಳ.
ಹೌದಾ? ಒಂದು ನಿಮಿಷ. ಹಲೋ ಹಲೋ
ಮ್ಯಾಮ್. ಹಲೋ
ವೀರೇಶ್, ಹಲೋ.
ಹಲೋ ಮೇಡಮ್.
ಕೇಳಿಸುತ್ತಾ?
ಹಾ ಮೇಡಮ್.
ಬಾಳ ಸ್ಲೋ ಕೇಳಿಸುತ್ತೆ.
ಇವಾಗ ಕಳಿಸುತ್ತೆ ಮೇಡಮ್. ಮಿಡಲ್ ಸ್ವಲ್ಪ ಲೋ ಆಗುತ್ತೆ ವಾಯ್ಸ್.
ಅದು ಫುಲ್ ಲೋ ಆಗ್ಬಿಡ್ತೈತೆ ಮ್ಯಾಮ್ ಮಿಡಲ್. ಹಲೋ ಮೇಡಮ್. ಪ್ರಭಾ ಮ್ಯಾಮ್. ಪ್ರಭಾ ಮ್ಯಾಮ್. ಮೇಡಮ್ ನೀವು ಇಯರ್ಫೋನ್ ಯೂಸ್ ಮಾಡ್ರಿ ಮೇಡಮ್.
Hello, Prabha ma'am. Prabha ma'am. Hello, Archana.
Ma'am, sorry, ma'am.
Can you continue session?
Actually, Prabha ma'am is online, ma'am. She is trying to use the earphone, ma'am. Hello, Prabha ma'am. Hello, Prabha ma'am.
Archana? Archana,
Yes, ma'am.
you take
Hello.
over the session. You take over the session.
Okay, ma'am.
Continue.
Okay, ma'am. Actually, madam has to stop that sharing screen, ma'am. Then only I can continue. It's okay. Till that, I will explain the how to use the Scilab and Maxima in software.
Yes, please.
Just check it. I'm going to share the screen. Hello, Prabha ma'am. Okay.
It's okay, Archana.
Yes, ma'am.
Yeah, you continue. You share the screen and you continue.
Okay, ma'am.
It's there, no, with you?
Actually, I don't have PPT, but I can explain the software, how to do the commands, ma'am.
Direct online you go. Hello.
Okay. Okay.
Yeah. And one or two problems you can.
Yes, ma'am.
Okay. Dear students, participants, please cooperate.
I think everyone will be able to see my screen.
Yes.
Okay. So let us continue. Actually, when you open the Scilab software, we have different versions. Using 5.4 version, you can also, if you have a older version of system, then you can use the lesser version of the software. So let us consider how to do the matrix concepts in Scilab software. So first of all, when you want to enter the matrix, then you are going to type the elements of the matrix. So before that, just if you want to consider the addition of two elements. So for example, 2 plus 3. So automatically you will get an answer. Just a minute. So this is the main Scilab 6.1.1 version. That is the console command and console.
Archana?
Hello. Yes, ma'am.
Hello, Archana. Can you audible now?
Yes, ma'am.
Okay,
So
I'll
will you
continue.
continue, ma'am? Okay, you can continue, ma'am.
Okay. Hello, can you see?
No, ma'am. screen
Can you
is not
see?
there. No, screen
Ma'am,
you
you share
have
your
not.
screen, ma'am?
No, screen share agila.
Illa.
No,
ma'am, ಇನ್ನೂ ಆಗಿಲ್ಲ ma'am.
Just a minute. Share ಮಾಡ್ತೀನಿ ನಾನು. Can you see?
Yes, ma'am. Yes.
Can you see?
Yes, yes, yes.
Okay, I'll continue. See, the echo to display the commands or other input typed by the user. Execute to run the program to carry out the instructions specified in a command. Returns provided by the command by the computer in response to command. The prompt, just now before I told what is the difference between the prompt and the cursor. Without the prompt, we cannot give the user to input. The cursor is a blinking line or a box on a computer, the screen that indicates the next location for the data entry. The program is the set of perfect sequential instruction to solve a given problem, to solve a particular solution. Then directly we'll go to the what here. Can you see the next screen? See, just now I told the what here, the Scilab Console. The Scilab Console is a graphic user interface. Hence, it can be used analogs to calculator as well as programming purpose. Then these two are the console. This is for a 6.11 and this is for a 5.22 version.
hello, ma'am.
Hello, Prabha ma'am.
Hello.
Kavita ma'am, ಒಂದೇ ನಿಮಿಷ wait
ಹಾ
ಮಾಡಿ.
ಮೇಡಮ್ ಇಟ್ಸಿ. ಹಾ
Hello.
ಹಾ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಮ್ಯಾಮ್.
ಕೇಳಿಸ್ತಾ ಇದೆನಾ?
ಹಾ ಕೇಳಿಸ್ತಾ ಇದೆ, ಹೇಳಿ ಮ್ಯಾಮ್.
Okay. See, in the prompt in the Scilab, the prompt, if you type a 2 plus 3, then if you want give the any variable, it automatically takes what their answer is a 5. Then here the next example, the a is a 5, that is it displaying the equal sign is what here, it is assignment operator, the 5 is assigned to the a here, it is displaying a to 5. Yes, then ending with the expression with a semicolon suppresses the echo of the output of the expression. The expression evaluated the result assignment, but the result are not echoed by trying this following command. You see, a equal to 5 semicolon are written. Semicolon means suppresses the what here, the echoing. Echoing means it is not displaying. Yes. Now we can combine what here. Notice that the prompt dissipates immediately after this without echoing a equal to 5 here. You observe here, this is a equal to 5. Now you can see here the command separated by semicolon and comma. Then you can observe here the one more example. A equal to 100 I written semicolon, B equal to 200 comma, C equal to 300 semicolon. Then here semicolon means it is a suppressing the echoing. Therefore, A equal to 100 and C equal to 300, it is not displayed, but B equal to 200 is displayed here. That is the observation here. And one more thing, when you want to edit a command means you can use a left arrow and a right arrow keys, also backspace key. If you want to see the previous commands means you can see what here up arrow and a down arrow keys, also you can go in the console editor. Yes. Now you can go for the editor. Then editor we can launch with the two ways. The first way is we can go for here console is there. Then it is just launch side notes, and otherwise you can go for the application the side notes, And editor means you can write the program on the editor, and this is the execute command, and this second one symbol is the save and execute command. Then you can see when you are writing the program, these all you can see with the lives. Then how to create the variable? How to create the variable means here the equal sign operator is there for creating the variable here. This is the creating the variable. Now you can see addition for the plus, minus for the subtraction, into for the multiplication, slash for the right division, and backslash for the left division. Right division means x by y, then left division means x backslash y, means x by y, means y by x it is. For powering, the cap is there, and power is the double star is there here. Then variable names, the rules of the variable names are the first 24 characters are taken to in account. The ASCII characters also you can use it A to Z or small a to Z or capital A to Z, and digit from 0 to 9 are allowed. With additional characters, person sign and underscore sign and hash sign and dollar sign and everything you can use it. The first rule is there. The first character must be a letter. And also very important note that it is a Scilab is a case sensitive. The Scilab is a case sensitive. Upper and lower case are the different. Now you can see one example here. A assigned, the 2 is assigned in the capital A, and a small one assigned in the small a, and the variable names are same, but capital A and the small a are used. But it is A and capital A are taken to be different variables in Scilab. But in mathematics, small a and capital A using both are the same. Yes. Now, similar, you can go for the comment. How to write the comment here? Comment means when you executing time, the Scilab will be ignoring. Means here the comment in the Scilab is the double slash is for used for the Scilab for the comment. This is the comment I written here. This is the one comment, and this is also another comment. Another comment I written after the command. What is the command is there here? X equal to 2 plus 3. That is the sum of 2 and 3. Therefore, this is also comment. You can in between you can use it, or in the after the command you can write it. The comment will start with what here? The double slash. And also you're familiar with what here elementary functions. The trigonometric functions sine and cos are there also available in Scilab. And also trigonometric functions for the degrees. When you have a degree, then the sine degree, cos degree, these are the built-in function in a Scilab. These are the trigonometric functions, means inverse trigonometric functions and hyperbolic functions and inverse hyperbolic functions. And similarly here square root and exponential means e raised to x. If e raised to x if you want, means you can use it exponential. And sum, minimum, maxima, these are the functions, built-in functions. And absolute of a function is there, and log function, log base 10 functions, many more functions available in Scilab programming language. And before that, the relational operators. Relational operators, we need two variables, A and B. It is and is a logical and, or is logical or. This is a tilde sign is a logical not. Equal, double equal is what? Tell me, relational operator. It is double equal means it is equal. A equal to B, and next is not equal to B, and A is not equal to B. You can use it a tilde sign and equal, or greater sign and a less sign. And A is less than B, and A is greater than B. A is less than or equal to B. A is greater than or equal to B. These are the relational operator and the logical operators. The Boolean values means it has a two values. One is a true and false. True means percent %t or percent capital T. False means percent %f or percent capital F. These are the Boolean values. Boolean values means true or false. Now next we have to how to create a matrix real values. See, the matrix real create values means using a square brackets, open bracket and close bracket. Beginning and
Hello, Prabha ma'am. Prabha ma'am.
Hello. Hello.
Yes, ma'am. You can continue.
Create a matrix of a real variables. Using a square bracket, left and right, we can mark the beginning of the end of the matrix, and commas to separate the values of a different columns, semicolons to separate the values of a different rows. You can see the one example, A1, 2, 3, semicolon. And 4, 5, 6. You can observe here. Without a comma, we can use the spaces also. There are built-in matrix functions are there. I for identity matrix, 0 for zero matrix, 1 for unit matrix, diagonal, many more matrix built-in functions are there. You can see diagonal, inverse, determinant, size, rank, minimum, maxima, product, sum, length, trace. You can see the examples. Directly we'll move to the what here, the operators of a matrices, plus for addition, minus for subtraction, multiplication and division and all. Now directly we'll go to the program. Write a program to find the addition and subtraction of a matrix. Directly I'll go to what here. See. Hello. A, input the matrix A, B, input the matrix B, and size of A should be equal to size of B, then C equal to A plus B, and D is A minus B. The addition of a matrix, two matrices is subtraction of a two matrices. If a size of A and size of B are not equal, then the addition of subtraction of matrix is not possible. This I can run. Enter. I'll show you here one next running. Just a minute, I'm opening a Scilab. See, output look like this. Enter the matrix A. Now you can see here. The same program I will run. Just a minute. I'll open here. See sum and difference of the program. I'm running. It is giving enter the matrix here. I'm giving the 2 cross 2 matrix. Yes. And second matrix I'm giving. Yes. Now you see, observe here. The given matrix A is, and similarly the given matrix B is the addition of a 2 matrix and subtraction of a 2 matrix. See, 1 minus 1 is 0. The subtraction 2 minus 2 is 0. Then this is what you are getting the output. Yes. Similarly, you can go for the another. Second one for the multiplication, you can observe here. See, for the multiplication program, now observe, input the enter the first matrix, input the enter the second matrix. The first matrix is away displayed and the second matrix is also displayed. This is, you observe, very important here. Note that the size of A means the number of row and columns. M is a row and N is a column. Size of B. Here also the number of rows and columns means K is a what here? K is a row and L is a column. For multiplication procedure, the N must be equal to K. Why N must be equal to K? Then only we can multiply the two matrices. For that condition, if N should be equal to K, then only we can multiply. The C is equal to A into B. Then the display the multiplication matrix is C. Otherwise, invalid order for the multiplication. Now I will run this program. Now you can see we can give the what here, the multiplication. I'm giving the 2 cross 2 only. You can observe. The second one also 2 cross 2 I'll give here. Now you can see first matrix and second matrix. Then this is what the multiplication, the matrix. You can see here the first and this is the first matrix, second matrix and multiplication here. The addition of a matrix we saw and multiplication of a matrix you saw. Then we'll go for the what here, trace and transpose of the matrix. Trace means it should be a square matrix and sum of the diagonal of the matrices. Then input enter the matrix A and displaying the matrix A, and size of A means it is a M cross N. It is a row and column. Condition is what? If M should be equal to N, then only we can find the trace. The trace is equal to what here? Trace of A is equal to, we are assigned in the T. The trace of a matrix is T. Then transpose means I told here the single quote for use for in the matrix, it is a transpose. Therefore, the transpose of a matrix is displaying as a C. The output will look like this. When you entering the matrix 1, 2, semicolon 3, 5, the matrix A is 1, 2, 3, 5. Then trace of the matrix, sum of the diagonal elements is 1, 5 means it is a 6. The transpose of the matrix is row changes to column, column changes to row. This is the output look like this. Then we'll go to the next is the write a program to find the rank and row reduced echelon form. Yes, then already we are familiar with, we know that the built-in function rank. Rank means it is automatically finding a rank of a matrix. The row reduced echelon form, RREF means row reduced echelon form. Row reduced echelon form means what here? We are getting a built-in functions in the Scilab here. Just we can take it, input the matrix A and display, then using the rank and RREF means row reduced echelon form. Using those two functions, we can find what here, the rank and the row reduced echelon form, and we can display it. The output look like this. We are given the input command, input of a matrix, and we are finding the rank of a matrix and a row reduced echelon form here. The next is the what here? The inverse of a square matrix is very, very important. For finding the inverse of a square matrix here, it is using the Keller-Hemington theorem. The Keller-Hemington theorem, what it says, the every square matrix satisfies the character equation. Then what is the character equation? Character equation is the determinant of A minus lambda I is equal to 0. Then a minus lambda I equal to 0, it is also called, it is a eigenvalue of the characters roots of the equation. Character equation, if you're solving, will get the lambda values. Those lambda values is called what here? Eigenvalues. But after solving this, we are getting an equation. That equation will be satisfy always the every square matrix, satisfy the characters equation. One example we're taking here, you see here, using Keller-Hemington theorem, find the inverse of the matrix using matrix method. You see here, the character equation is what here? A minus lambda equal to 0. The determinant we can equal to 0 means we are getting, after solving, we'll get lambda square minus 7 lambda plus 6 equal to 0. That implies lambda minus 1 into lambda minus 6 equal to 0. After solving these equations, we got it a lambda 1 and lambda is equal to 6. These two values are called eigenvalues. We don't want the eigenvalues. Our main is what here? To find the inverse of a square matrix using a Keller-Hemington theorem. Then once we're getting this equation should be satisfy what character equation. Therefore, it should be replaced by the matrix. Therefore, that becomes a square minus 7a into 6 into I. Now, this is what here the Keller-Hemington theorem. Using Keller-Hemington theorem, the characters equation will be satisfy the A, means square matrix satisfy the A. Using this, then we have to find the formula for the A inverse. Then I'm not displaying in detail, I'm explaining. Here we got it after simplification. A inverse is what we got it, 7i minus a divided by 6. 7 means what? Means that is a trace of a into I minus a divided by the determinant. Trace of a is a 7, determinant of a is a 6. Therefore, 6 can be written as a determinant a, 7 can be written as a trace of a. Now we are got it a one formula. Using this formula, we can find it the inverse of a square matrix using this Keller-Hemington theorem procedure. Yes. So similarly with the 3 cross 3 matrices. For 3 cross 3 matrices also, you can observe here, we got it what here the characters equation. The characters equation satisfy the Keller-Hemington theorem means we got it this the A satisfy the characters equation. For after simplification, we got it this one. You observe here, A inverse is a square minus 6i plus 9i divided by 4. Yes. Then A inverse can be written as a square. 6a. 6a is same as the trace of a, and 9 is what we got it, the trace of adjoint a. Then trace of adjoint a. Then determinant of a is a 4. That this equation should be replaced by, this is a symbolically a square minus trace of a into a and trace of adjoint a into I. I is what here? It is a unit matrix divided by the determinant of a. Then in the both in order 2 and order 3, we got what here the formula. Using the same formula, we can find the inverse of a square matrix. Now you can see the program. Now observe the program here. Now write a program to find the inverse of the matrix by the Keller-Hemington theorem. Yes, input, enter the matrix we are taking, size, it should be a square matrix. That is we are checking here, m equal to n, then only we are checking, and the characteristic polynomial we find out, and determinant also we calculated. Why here determinant we calculated? There is no adjoint function in the matrix. The adjoint should be calculated using what here? Determinant A into inverse A, that is the adjoint. Now we are displaying the adjoint. What is necessary for adjoint to finding? We need to find the inverse of a square matrix. If n equal to 3, then just now we have formula we did, that is a square minus trace of a into a, trace of adjoint a into I means what here? The identity matrix order 3 here, divided by determinant a. Similarly, n equal to 2. N equal to 2 means the trace of a into the identity matrix 2 minus a divided by the determinant a. Once we calculated a b here, b are what? Tell me, these b are order, this is for order 3 and n equal to, it is for order 2. Only order 2 and order 3 we have calculated the inverse of the square matrix. Then here we are displaying inverse of the square matrix using a Keller-Hemington theorem, inverse of a square matrix using the built-in function. Built-in function is already we are here in the Scilab, that is the inverse. Then if it is m is not equal to n means it is displaying the in order. Now you can observe here, the enter the matrix we given 3, 2, 4, 3 means the 2 cross 3 I given. Then the characters column is displaying. Then adjoint is displaying. You observe here the inverse of the Keller-Hemington theorem and inverse of the using the Scilab function, both are the same. Yes. Now next we can go for the what here, the system of equations written in the matrix form Ax equal to B. If B is 0, that the equation is called a homogeneous equation. B is not equal to 0, it is called non-homogeneous equation. Already you are familiar with the theory here. Then rank of A should be equal to the augmented matrix rank, that should be equal to n. Then the system is a consistent and in unique solution. The same condition we can use in the program also. The rank of A is not equal to rank of augmented matrix, then there is a no system, there is a no solution, means system is inconsistent. The rank of A is equal to rank of augmented matrix, and also it is a less than n. The system is consistent, but it is infinitely many solution. The same thing we written in a programming part. See, this is a trivial solution. If RHS is 0, then homogeneous equation, we are getting a trivial solution. If a determinant A, we are finding, if determinant is not equal to 0, then A has a trivial solution. It is equal to 0, it has a infinite number of many solutions we'll get. But you see the non-homogeneous linear equations, you can observe inputting the matrix A and the constant B also. Then you are finding the augmented matrix here. The augmented matrix, we are displaying a C here. The rank of A we are calculated, and the rank of augmented C means what here? The augmented matrix. See, augmented matrix. You can observe here the augmented matrix, how we are written here. Augmented matrix, and rank of C means we are finding the augmented matrix. The rank of R1 should be equal to R2. R1 should be equal to R2, and R1 should be equal to the R1. Then the system is consistent. We can find the what here? X equal to A inverse into B. X equal to A inverse into B. Then we can solution of a system of X we can write. If it is false, else if R1 should be equal to R2, but R1 is less than n, the system is consistent and it has a infinitely many solution. If it is not equal, the system is inconsistent and it has a no solution. This is what the conditions. Also using a determinant, also you can write it the one more way. Now you see the look like this. Your see, rank of coefficient matrix is 3 and rank of augment matrix is 4, and 3 is not equal to 4. Therefore, we got it the message here output is the system is inconsistent and it has a no solution. Yes. Directly we'll go to the maxima. The maxima is a symbolic based mathematical software providing a number of functions for algebraic manipulation, calculus, operations, matrix, and linear algebra and other mathematical calculation. Maxima is open source computer algebra system. Yes, it is a open source maxima system. Maxima also we can, web page is maxima.sourceforge.net. Maxima can be installed with this website. Yes, there are, when you installing, after installing a maxima, you can look like 3. One is a WX maxima, one X maxima, and one more is maxima for console. You can use a WX maxima. Why you have to use a WX maxima? You can use graphical user interface. You can figure look like this. Yes. Now, before going to the maximum software, you have to keep it in mind. It is also case sensitive. How Scilab is a case sensitive for when you defining a variables and typing a commands also. Maxima is also case sensitive. And one more thing, listen here. In every line, maxima should be end with a semicolon or a $sign in the maxima. Compulsorily, the maxima should be end with either a semicolon or a $sign. The semicolon will be terminates the input expression and resulting output will be displayed. $sign is a terminates an input expression. This is also terminate the input expression, but result will be not displaying. Like in the case of a Scilab, If you give a semicolon, it is not displaying in the console, but here in the dollar sign, it is not displaying the console. You can observe here, %I indicates the input line, 3 indicates the line 3, and %OOR there, observe here, these are the output line 1, output line 2, output line 3. These are the meaning here, the meanings of a in maxima. Now we'll directly, before going to the execution of a program, some basic commands used in commands. Yes, what is a comment in a maxima? Comment is a maxima is a start and end with a slash and asterisk, end with a star and slash. You see here, this is the comment. In between these two, if you type anything that will be indicated in the maxima is a comment. And what is the assignment operator? But in Scilab, equal is assignment operator, but in maxima, colon is assignment operator. Whatever you assigned in RHS, that will be stored in LHS. For example, here A:10 means A:10 means what here? The 10 is assigned to A. Similarly, A is assigned to B. See, you see, kill X. Kill X is, it is used to kill the particular variable X, means what are it is stored in a X value, that will be releasing. Similarly, X and Y. Kill X and Y means it is used to kill the variables X and Y. Kill all means it is used to kill all the variables previously stored in the program. See, here one more command, print is there. Print means it is evaluating all the expression and displaying the expressions 1 to n, one after the other, from left to right. How it is displaying? Expression 1 and expression 2 and expression 3. Left to right it is displaying. Yes. Where it is displaying? On the console it is displaying. See here, just I use the print welcome is, the welcome will be displaying. Yes. Now quit. Quit means what here? Terminate the maxima session. Note that the function must be invoked with a quit. Just not quit. Quit with open and close parenthesis with a semicolon, or open and close parenthesis with a dollar sign. Not only quit itself. Yes. Then few more commands to learn here. For differentiation, if you want a differentiation with anyone, here expression you can give it. X is with respect to X, nth derivative. It returns what here? The first statement, it returns what? The nth derivative of an expression with respect to X. The second one, n is not there. Therefore, it is defaultly, it will take the first derivative. Yes. Now, one more here, it is a function. Colon equal means it is a function definition in a maxima. Later we'll come to know. Now you can see here the simple program. Write a program to find the nth derivative of e raised to ax, taking n equal to 2. Now that you can see with here. You can see y colon exp of a into x. I will write a semicolon. After this, I will write a differentiation. What here? Y comma x. Okay, just to observe what we'll be getting here. I'm writing a display statement. I'm using display. This is what send all the maximum to running purpose. You see, observing. See, y is what here? %e. The %e means what? E is the exponential there. For built-in, it is displaying the %e in the maxima, e raised to x. What is the derivative of e raised to x? A into e raised to x. If you want a more than one derivative, you can use it a for loop. How to use it a for loop? For I colon 1 th are you through how much? Up to 4. Do open parenthesis. Now I'll close it here. Up to here, I'm closing here. Now you can run it. Observe here. Can you see? See, The first derivative of e raised to x is a into e raised to x. Second derivative, see, I not written here. Observe here. First derivative of e raised to x is a into e raised to x. Second derivative of e raised to x is a square into e raised to x. Third derivative of e raised to x into a cube into e raised to x. Yes. Yes, 4 derivatives. Similarly, we can find the derivatives with the sine function also. I can give a sine functions and observe the derivative of sines, first and second, third derivative. See, derivative of sine is a into cos ax. Second derivative of cos means what here? Minus a into a square into sine ax. You can, like that, you can go on change what here? The trigonometric functions and hyperbolic functions, and also we can do for the logarithmic functions also. I'll show you for the hyperbolic functions. Just to observe for the hyperbolic functions. See, derivative of sine hx ax is a cos hx. Derivative of cos hx is sine hx. There is no negative. In trigonometric, derivative of sine means cos will come, derivative of cos is minus sine will come. But in hyperbolic, derivative of sine hyperbolic is a cos hyperbolic, and derivative of cos hyperbolic is sine hyperbolic. Then similarly, we'll go for the logarithm. Log. You observe here the log. Derivative of log ax is 1 by x and minus 1 by x square, and third derivative is 2 by x cube. This we can write it a plus b. Then what to get the answer, you can check it. Yes, derivative of what here? Log of x plus b is a by ax plus b, and the second derivative is a square by x plus b whole square. Third derivative is 2 times a cube divided by ax plus b whole cube. The one more function is e raised to x into, means expansion, that the last a into x into sine of this. There the same variable are there. I'm changing here. Here only second derivative I'm changing. See, this is what here? Y is equal to e raised to x into sine of bx plus c. Similarly, you can find the cos of bx plus c also. Sine of bx plus c. Let's just a minute. You see here, first derivative, what we got it here. First derivative of e raised to x into sine bx, and similarly second derivative of e raised to bx into c. This is applying the product rule. It is applying the product rule. Yes. After this, we'll go to the what here? The Taylor's expansions. I'll explain in this. See, these all what tell me the derivative of cos x and all. Now we will go to directly to the Taylor's series. These all are explained in the Maxima software. See, observe. Taylor's. See, for Taylor's series, the Taylor is a function. Taylor is a function. Y comma x means y is a given function. X is with what here? X about x is equal to 1. It is up to x raised to 4. Means up to x raised to 4, it is expanding. You see here the question. The Taylor's and Maclaurin series expansion sin x about x equal to 1 and x equal to 0. When x equal to 1 is called, it is a Taylor series. When x equal to 0 is called, it is a Maclaurin series. Both we can expand using a Taylor function only. Both for the Maclaurin series, for the Taylor series, we can use the Taylor function only. Other than 0, it takes it treat as the what here? The Taylor function, and it is a 0. It is a Maclaurin functions. Now we can run there this program in Maxima. X I'm giving. Y comma X 0 I'm giving here. 0 means what here? It is a Taylor series expansion, means Maclaurin series expansion. See, this is a Maclaurin series expansion up to the power x raised to 4. If you give a 1, the Taylor series expansion about x equal to 1. You can change any function. Instead of a expansion e raised to x, then you can use for the sin x also. Observe here for the sin x. This is the Taylor series about x equal to 1. About x equal to, you can give for x equal to pi by 4. Pi means what will happen? See, sin pi is 0. Symbols you can use it. See, about x equal to pi. Then if you give a 0, then Taylor series about that, it becomes a Maclaurin series. Like that only you can give any series, log series, sine series, cos series. In what all you'll solve in a theory classes, all functions should be expand using the Taylor's and Maclaurin series. The next is important. See, the some more commands used in Maxima. These are the very, very important. The trig reduce. Trig reduce means it is reducing the trigonometric functions. Means it combines products and powers of trigonometrics and hyperbolic sines cos of x into those multiples of x. Yes, the trigonometry rational. Here also canonical simplified. Canonical simplified means it display in the tan form. Tan form. Yes, it is RAT simplification means a rational simplification. Then this is very, very important. This is evaluation. Evaluation for the expression particular. See, if you write like this, what here, dy by dx at x equal to 1, or you are finding a angle between the radius vector and the tangent at x equal to theta equal to pi. That time we need very, very important evaluation. Evaluate the expression for expression for expr environment specified by the arguments 1, 2, 3, and so on. This will come to know in the programming part. Now you see the first program. Write a program to what here? Angle between the radius vector and the tangent r equal to a into 1 minus cos theta. Already you're familiar with the formula. Tan phi is equal to r into d theta by dr. The answer is what we have. Phi is theta by 2. Now this we can run. Just I'm copying this one. We'll run there. Yes. Next. See, here a I taken as a 1, a is 1, r equal to a into 1 minus cos theta. Theta I had to take it from here only. Here side Greek letters are there, had to take it at theta. D is a differentiate with respect to theta. P I taken 1 by d, and the trigonometric radius and trigonometric rational. Trigonometric rational, that P, the tan phi is this, and the angle between the radius vector and tangent, you can observe the answers. Let's see. Tan phi is a tan of theta by 2. The angle between the radius vector and the tangent is a tan. And means tan inverse of tan theta means theta by 2. It won't display the theta by 2. It is understood a tan of tan means tan inverse of tan is theta by 2 only here. See, instead of this, we can give what here, the particular value, evaluate. Eval for what angle we can give, comma, theta. Theta, what I'll give, theta is pi by 2, I'll give pi by 2. Now I'll run it. Now what we'll get here? The answer, observe here. See, when tan phi is a tan theta by 2, when theta is given as a pi by 2, pi by 2 means how much we got it here? Pi by 4. This is your answer. The angle between the radius vector and the tangent is pi by 4. See here what command we given here. This is a very, very important command. Evaluate means the tan theta means the phi value we are finding at theta is pi by 2. Angle between the radius vector and the tangent we are finding what with what point? Theta equal to pi by 2. Then what we are getting? Yes. Similarly, we go for the next. Similarly, we can give any functions here. See here, one more example are there here. Write a program to find the angle between the radius vector and the tangent for the curve r equal to a into 1 minus cos theta at theta equal to pi by 4. Yes. See, a into 1 minus cos theta, again differentiate with respect to theta, and similarly we find out here. The answer is what here? When theta is evaluate, theta is pi by 4, means we got it at pi by 8. Similarly, many more examples are there. One more thing is very, very important here. You see, some angle between the radius vector tangent negative will come, but we want not negative. For in the negative case, then this is a very, very important here. In the negative case, if phi means what here? Angle between the radius vector and the tangent. If the angle between the radius vector tangent we got it a negative, means always have to add with the pi. This is here. Now you can see, if a pi is greater than 0, then the angle between the radius vector is as it is a pi. Angle between the radius vector is as it is a pi. But if it is less than 0, then you can add it this. This is very important here. We'll change it this. Okay, you can see here. We will change here. See, if we'll do the +1, we'll run it. See, observe here minus pi by 4, we got it. Actually, minus pi by 4 we don't want. Positive we want means you have to write here the condition. If that value is negative, if the value is negative, see I told, if a value is negative, then have to add with this plus pi. You have to use that time, it is a condition. If phi is greater than 0, then as it is display, otherwise you can write it what here, 5 plus pi. This is very important. Then similarly the last here, last but one, finding the curvature of the given curve. Finding the curvature of the given curve. Everyone you are familiar with the curvature, radius of curvature formula you are familiar. The curvature is reciprocal of a radius of curvature. Radius of curvature is 1 plus y1 square raised to 3 by 2 divided by y2. The curvature is what? K is the reciprocal of that. Similarly, this is a radius of curvature for the polar curve. That should be radius of curvature is a reciprocal of that. It is Cartesian curve and this is a polar curve. Then here find the curvature of the curve y square equal to 4ax. It is a Cartesian. Cartesian means that you find the first y1 derivative and y2 derivative. Use this formula and find out the curvature. Curvature at point x equal to 1 and a is 1. Now you can observe here. A is 1 is there. Y is given function is square root of 4ax. Square root of 4a into x and differentiation with respect to x and second derivative, 2 means second derivative directly, and curvature. Curvature means what here? Reciprocal. y2 divided by 1 plus y1 square raised to 3 by 2. This is what? The formula. This is the what? The formula. Then this is a RAT means a rational simplification. any rationals are there, it is a automatically this function will be simplification, the rational simplification. After that, what we did, the curvature of the curve at any point is KV display. The curvature of the curve at x equal to 1 is, see, this is very important, evaluate EV K for what point? X equal to 1. X equal to 1. Now you can, that time you can display. This is the output way. Yes. This is the one more finding the curvature of the curve. Curvature again, you can use it the formula. Same formula what we'll use in the theory part, the same part. Then you can give the, for at point means evaluate that point. You can give it, then get the answer is this. The next is the plotting. Plot means it is a plotting the graphics. Plotting the graphics, you can observe here. See. I will run difference, you see. Just a minute. Plot. Oh, the semi. No, I can. Sorry. A is not. See, A had to give one not directly. And A are not assigned. No, that's why it is giving error. You can see it. Yes, this is the catenary. Actually, want to give here A. First, have to assign a value. A is 1 or A is 2, like this. Then there you can stop this. You have to give the A. Say not given A value, no, before. That's why it was given. It is a refusing given error. Yes. Now you observe here WX. Both you observe WX plot and only plot 2D. See what you observed plot 2D and WX plot. Plot 2D will be displaying the another window, graphic window, that output will be displaying the graphic window. WX plot 2D means it displaying here itself. Yes, you can output will be displaying after the input commands only in the same window, in the WX maxima window only. Now once again you observe the color is what here, the blue is there. If you want to change the color, you can give the color command. Now once again you observe here the plot command. Now I'll run. See, you can see output, see, separate graphic window. Yes. Plot 2D and this. See here A is 2 I given. There A and minimum and maximum title is a catenary. Like this you can plot any standard curves. Any standard curves. If you want to plot this, we can plot it. Yes. Now we can run here. It is displayed. You can observe, see. This is what here? Asteroid. Asteroid means here a WX plot x to 2 by 3 plus y raised to 2 by 3 is equal to 2 raised to 2 by 3. The X range I given -3 to 3. Y range is also -3 to 2. Title is what a title? You can see the title. You can see, observe here. The title is asteroid. Yes. Like that, you can draw any curves, standard curves, using a WX plot or a plot 2D. Instead of this WX plot, if you return a plot 2D, this output will be displaying where? In another graphic window. See, this is the graphic window. Yes, that is the difference between these two. Yes, thank you. If any doubts or questions, means you can ask. Hello? Hello?
Ready, ma'am?
Any students, you have any doubts? In maxima, any functions?
Just a minute. I will unmute the students. So, dear students, those who have any doubts, you can ask now. Just unmute yourself and ask the questions. So if you have any doubts, then you can unmute yourself and ask the questions. Ma'am?
Hello?
Okay, ma'am. I think no one is asking.
Hello, dear students. If any, hello?
Yes.
Kavita?
Hello.
Hello, Archana.
Share screen stop ಮಾಡ್ಬಿಡ್ಲಿ?
Yes, ma'am. Share. Stop ಮಾಡಿ ma'am. Kavita ma'am, if you have any doubts, you can ask now, ma'am.
Okay.
Prabha ma'am?
ಹೇಳಿ ಮೇಡಮ್.
I think no questions were there, ma'am.
Then ಅವರು ಕಂಟಿನ್ಯೂ
Okay.
ಮಾಡಕ್ಕೆ.
One second. Hello?
Yes, ma'am. Tell me.
Madam, in tracing a curve, hello?
Tell me.
How to change the color in
Color command is there. Color
co-
command is there.
command,
You want me to show?
yes, ma'am.
Okay. Again, I'll share it. Okay. In maxima, I'll show you.
Madam.
See here, after this comma, square, COLOR. Color, what color? Blue, red or RED red. Okay. Color red are given. Okay. Color red. Now you can run. See, it is a red. Can you see?
Yes, ma'am.
That is the color is there. Title for the titles and color for a color. The
Okay.
default is blue color it comes. Other than blue means you can give black also. Black. Now you can run black means run it is that color will become a black. Now you can observe it is executing. See, it is now black.
Okay. Okay, thank you.
Okay. So do you have any doubts? Prabha ma'am?
Okay.
I think no one has doubts.
Okay, they'll continue our continue ಮಾಡ್ಬೇಡಂತ ಹೇಳುವ principal.
Now I request our principal ma'am, Dr. Umavi Nelle, to say few words regarding this workshop. Over to you, ma'am.
Thank you, Archana. Good afternoon, everyone. Respected principal, IQAC and NAC coordinator of RTS College. Respected Prabha madam, today's resource person, the organizing secretary, Kavita madam, Archana, and Viresh and Shweta, and my dear students and other participants. This workshop under NEP syllabus about calculus and algebra, it is not new to the mathematics students or mathematics teachers. But as the technology develops, we should not lag behind. We should adopt the each and every step of the technology, then only we can survive in this competitive world. Our department, mathematics department, always takes this challenge, and they are always on the toes to do something different. And this is our second workshop. The day before yesterday, we have collaborated with one more college. There also mathematics department has organized this workshop. And today we are very happy to say that we are collaborating with RTS College and organized and shared some knowledge about the how to plot the different graphs and calculate different programs with the Scilab. These knowledge, dear students, about MATLAB, Scilab, and Python, this is a necessary for coming era, that is to survive in technology. So how wonderful we can change the every parameters and we can plot these graphs. I request all the students of KLSK Arts, HSK Science Institute Hubli and RTS College, take this opportunity in this pandemic, as already all of us know that we have organized so many online programs. Further, we will bring the other programs in different subjects with the different softwares, as we are in once again locked down, semi-locked down, we can say. So I request the students to take this opportunity and grab these opportunities and enhance your knowledge with all the resource person. I thank principal of the RTS College Ranebennur giving this opportunity to collaborate with your mathematics department and sharing our knowledge with your students and your faculty. Further, I also request we will continue in other subjects these collaborative activities. I thank Dr. Prabha madam, Dr. Archana, Viresh sir, and Shweta, and all the participants for the patience hearing. Thank you one and all.
So thank you, ma'am. Now I request the principal of RT College, ma'am, Kavita ma'am, is your principal is available?
Sir, see her here, sir.
Okay.
Yes,
So, sir, I request you to do the presidential address. Shri C.A. Harrier, sir. Over to you, sir.
Okay. Good evening to all the participants of this afternoon session. Dr. Prabha Madam and their team have collaborated with our college mathematics department because of the beginning of this NEP is very hurriedly introduced. Maybe of course, whatever it is, we have to prepare as much as possible. Our students should not be lagged, as Nalde Madam has already told to us regarding the technological issues are going to be introducing in mathematics. And till now, last year, up to last year, we have no practicals in mathematics. Now onwards, it is greatly and inviting all the mathematics teachers, because only the subject mathematics will be only theory, and rather other subjects will be having a practically. Students should be trained now. And usual theory is always theory, because only in 1 hour teaching we cannot train the students. And this time it's a NEP has introduced the mathematics as one of the practical by making use of the technological yeah, technical issues in connectivity with the programming and other things. And it's there in computer. They are doing the little bit mathematical and collaborations, but now it is a great opportunity for the mathematics teachers can also work with the practically and train the students and have a it's usually this practical means it's a very close assembling with the students. Now closeness will be developed, and also students participation in learning more and more things in relevant to. And it's I don't think it when I was a mathematics student as a PCM combination in degree, I don't understand mathematics is going to having a practicals. Now it is really a dream. We our students are going to learning the mathematics practicals. Okay, and now it's I must say all the participants, you must take this kind of opportunities, and wherever you have a this kind of online, it may be offline training programs are there. Please join and make yourself knowledge, because the upcoming days may be having lot of calculations, lot of things are going to be works have been there in the future days, because the most of the graph and other things researches are going to be and 4-year transfer. And I think I would like to tell the mathematics department, you better do more and more for the 4-year, because most of the practical applications, Michelson's interferometers have been using this 4-year transfers. One NEP programs you can do for the students, and most of the series and practical applications, and only for doing these seminars and others, better you can go for the workshop and take the students 2 to 3 brainstorming sessions, and so that they can be more and more inculcating their mathematical ideas, and they can also contribute something towards the 4th year. They have a project submissions. During the project submissions, definitely these kinds of mathematical approaches are going to be very useful, and survey works, and probably some of the surveys they are doing with a mathematical fitted formula, and they can do better and better contribution to the society, college, and nation. And with this word, I must thanks to all the participants and all the organizers of this program. Thank you, one and all. Thank you.
So thank you, sir, for sharing your views. So before conveying vote of thanks, I request all the participants to switch on their video so that we can take a screenshot. I request all the participants to switch on their video.
Archana?
Yes, ma'am.
Also, you announced that the physics and zoology department will use the different softwares. Hello, can you hear me?
Yes, ma'am. Yes, ma'am.
Yeah. So announce that. So physics and zoology department will try to collaborate and will bring out something different online programs. So please try to join. Tell them.
So one more thing we want to share. Recently, our institute has become a nodal center for virtual lab. So which comes under the Department of Physics. And also we have one more collaboration in zoology. So next we are going to arrange some more programs related to physics as well as zoology. I request all the participants to participate in those events also. Just a minute. Okay. So we have taken a screenshot. So next, I would like to share the feedback link in chat box. So dear students, all of you should submit your feedback link by clicking on that one. I have shared that feedback link in the chat box. At last, I would like to thank our HOD, our HOD Dr. Prabhayas Mandalkari, to share her knowledge regarding the Scilab as well as Maxima practicals. And also, I would like to thank the principal of our institute, Dr. Umavi Nirlema, as well as Professor Machenali sir, for supporting to conduct this workshop. And then I would like to thank Shri C.A. Harrier sir for sharing their views in this workshop. And next, I would like to thank the convener of this workshop, Kavita S. Patil of Ranebanur College. Thank you, ma'am. And also, I would like to thank the Mr. Veeresh Manaj sir for anchoring. And at last, I would like to thank all the participants for your active participation in this workshop. So once again, thank you one and all.
Thank you, ma'am.
So those who have filled the feedback link, we can leave the meeting.